Welcome back to Kamal Kunj Home Academy, Encounter with Chemistry. In this session, we will discuss about how matter is made up of and the laws of chemical combination. Every matter in this universe are made up of microscopic particles called atoms. Now, the atoms are basic building blocks of all the matters. An atom itself is made up of still smaller particles. In the center, there is nucleus which contains protons and neutrons. Around the nucleus, electrons move in different cells. Now, these protons and neutrons are made up of smaller particles known as quarks, which are held together by still smaller particles known as gluons. That is, every matter in this universe are made up of microscopic particles called atoms. An atom itself is made up of smaller particles in the center. There is nucleus containing protons and neutrons. Particles called electrons move around the nucleus in different cells. Protons and neutrons are are made up of still smaller particles. Particles called quarks. Three quarks are held together inside protons and neutrons by smaller particles called gluons. By the end of 18th century, scientists recognized the difference between elements and compounds and naturally became interested in finding how elements combine together and what happens when elements combine. Now from 1789 to 1811, scientists proposed five laws of chemical combination. That is from end of 18th century to the beginning of 19th century. Scientists proposed five laws of chemical combination, and these laws are these five laws of chemical combination are: number one, law of conservation of mass. Number two, law of constant or definite proportions. Third is law of multiple proportions. Fourth is Gay-Lussac's law of gaseous volumes. And fifth one is Bokaro law. These 5 laws were proposed by scientists during this period 1789 to 1811, that is the end of 18th century and at the beginning of early period of 19th century. Now the law of conservation of mass was proposed by a prominent French chemist, Antoine Laurent Lavoisier. First law, that is law of conservation of mass, law of conservation of mass was proposed by prominent French chemist Antoine Laurent Lavoisier. In the year 1789. In the year 1789, Laurent Lavoisier proposed the law of conservation of mass. According to this law, mass can neither be created nor destroyed. According to this law, mass can neither be created nor destroyed. In a chemical reaction. It means mass of reactants will be equal to mass of products. That is, mass of reactants will be equal to mass of products. Now, for example, combustion of methane. When methane burns in presence of oxygen, it forms carbon dioxide and water, H2O. So here reactants are methane and oxygen, products are carbon dioxide and water, H2O. Methane here is 12 plus 4, it is 16 gram. Plus 2 into 16, it is 32. Two. It is 64. Total is 50 gram. Here carbon 12 plus 32, this is 44 plus 18, 36, total is 80 gram. That is, mass of reactants is equal to mass of products according to law of conservation of mass. Now the next is law of constant or definite proportions. Second one is law of constant or definite proportions. This law was proposed by Proust. Proust in the year Joseph Proust. followed by Joseph Proust. In the year 1799. According to this law, a chemical compound contains fixed number of elements in fixed ratio by mass. For example, if you take water, that is H2O, whatever be the source or origin or amount, it will always contain hydrogen and oxygen in a fixed ratio. Ratio here will be by mass 1:8. If 1 gram is hydrogen, then 8 gram will be oxygen. Whatever be the source of water or amount of water, it will always contain hydrogen and oxygen in the fixed ratio, that is 1:8 by mass. So this is the law of constant or definite proportion. Now the next is law of multiple proportions. Third one is law of multiple proportions. This law was proposed by John Dalton in the year 1803. This law was proposed by John Dalton in the year 1803. According to this law, that is law of multiple proportions, if two elements combine together to form more than one compound, then the ratio of the masses of the one element which combines with constant mass of other element are in simple whole number ratio. So according to this law, if two elements combine to form more than one compound, then the ratio of mass of one element which combines with constant mass of other element. Or in simple whole number ratio. For example, carbon and oxygen combines together form carbon monoxide and carbon dioxide, forms two compounds. Then the ratio of masses of oxygen, which combines with constant mass of carbon, is a simple ratio of whole numbers. For example, carbon combines with oxygen, it forms CO and CO2. When carbon combines with oxygen, it forms two compounds, that is carbon monoxide is CO and carbon dioxide is CO2. So in carbon monoxide and the second compound is carbon dioxide. Here carbon is 12 gram and oxygen is 16 gram. In this case, carbon 12 grams, oxygen is 32 grams. So, mass of oxygen, ratio of mass of oxygen is 1:2, 16 which is to 32, means 1:2, which combines with fixed mass of carbon, that is 12 grams, in the simple ratio 1:2. So, ratio of masses of oxygen here is 1:2, which is simple whole number ratio, which combined with fixed mass of carbon. So, this is a law of multiple proportions. Next is Gay-Lussac's law of gaseous volumes. This law was proposed by Gay-Lussac in the year 1808. Fourth law Gay-Lussac's law of gaseous volumes This law was proposed by Gay-Lussac in the year 1808. According to this law, when gases combine together or react together, it reacts in simple whole number ratio. According to this law, when gases react they do so in simple whole number ratio. If gases are at the same temperature and pressure, then they react in simple whole number ratio. If the gases are at the same temperature and pressure. And the last is Avogadro's law. According to Avogadro's law, equal volumes of all gases contain equal number of molecules at the same temperature and pressure. Avogadro's law was proposed in the year 1811. According to this law, equal volumes of all gases contain equal number of molecules. Equal number of molecules. At the same temperature and pressure. If the gases are at the same temperature and pressure, then equal volumes of gases contain equal number of molecules. Now we will stop here and continue further in the next session. Till then, goodbye and thanks for watching.